Alrighty, in this video we are going to be talking about area bounded between two curves, but in this case we're going to be talking about it in terms of dy. So let's say that we have right minus left instead of top minus bottom. Now for number 5, if I were to do top minus bottom, we have an issue. I could do top minus bottom, top minus bottom, top minus bottom here. That's fine, that's fine, that's fine, that's fine. But then after we hit this intersection right here, I'm going to have to do top minus bottom by itself. And we really don't want to do that because we don't know how to do that. Instead, we always want one function to be right and one function to be left, or one function to be on top of each other, completely on top of each other, or on bottom. Here, if I were to do right minus left, you would see that my sideways parabola will always be to the right of my linear function. So in this case, we are going to find the area between the two curves using the differential dy. Because we are using dy, this means that my bounds are going to be in terms of y to find where I'm starting and where I'm ending in terms of my height here. In order to do that, I have to set these two equal to each other and find what y is. I'm going to add y squared and subtract 3. So that is going to give me y squared plus y minus 2. That's going to give me y plus 2 and y minus 1, which gives me negative 2 and positive 1. So this means that my intersection, my y intersection, is going to be negative 2 and positive 1. So that means my bounds are going to be from negative 2 to positive 1. And then since I'm going from right minus left in terms of y, I have my sideways parabola first, so 3 minus y squared. And then my linear function, which is y plus 1. All right, so from negative 2 to 1, I have 3 minus y squared minus y minus 1 dy. Cleaning it up a little bit, I'm going to get negative y squared minus y minus plus 2 dy. And then I am going to solve, aka take the integral. Using my bounds of negative 2 to 1, you're going to evaluate that. And if you do that, you're going to get 9/2 as your answer. Verify that your answer is 9/2 units squared. All right, same thing for number 16. We want to find the area of the region enclosed by the graphs of the line y is equal to x minus 1 and the parabola y squared plus is equal to 2x plus 6. But finding the intersection algebraically to get your limits of integration, then use the calculator to find the area. Here's the thing about this one right here. I can't really graph this right here because this is an implicit function, but hopefully you know that that looks like a sideways parabola. So your thing, your 2x plus 6, might look something like, I don't know, that. Granted, remember that this might be wrong. It could be right. I don't know. But that's just a sketch of a sideways parabola. And then you have your y is equal to x minus 1, which looks something like this. So essentially here, you're going to find the area between the two curves, which is going to be this. Once again, I can't really do top minus bottom because here, the top and the bottom are going to be the parabola by itself, where these rectangles right here before we reach the intersections. So instead of doing that, we want to do right minus left because we can guarantee that the parabola is to the left of the line and the line is to the right of the parabola right here. But the only thing that's stopping us is how do we set this up, given that we have y is equal to x minus 1 and y squared is equal to 2x plus 6. Remember that this is going to be in terms of dy, so that means that my integrand should have y. So if I have y is equal to x minus 1, I have y squared is equal to 2x plus 6. What I can do with this y is equal to x minus 1 is square it, so that I get y squared is equal to x minus 1 squared. And that is going to help us because this is also y squared. And since they're both y squares, I can set them equal to each other and then solve. So that's going to give us x squared minus 4x minus 5 is equal to 0. X minus 5, x plus 1 is equal to 0, means that x is equal to 5 and x is equal to negative 1. All right, now, before you do anything in terms of putting my limits of integration being 5 and negative 1, remember that these are your x values. My limits of integration needs to be in terms of y because I'm doing dy. Because I'm doing dy, what I have to do is substitute these two back into one of the equations. Obviously, the easier one to do it is going to be this one right here, where we have x minus 1. So that means that y is equal to 4 and y is equal to negative 2. Which means that my bounds are going to be negative 2 to 4. So this is negative 2, and then this is 4 right here. Okay, so that's my first part. So I already have my bounds. That's great. What I need to do is right minus left. So my right is going to be my line, which is going to be y is equal to x minus 1. Now, because this has to be in terms of y, I need to solve this for x. So that's going to be y plus 1 is equal to x. So that I get my line in terms of y. Same thing for my y squared is equal to 2x plus 6. I'm going to have to solve this for x. So I'm going to subtract 6. Then I'm going to divide by 2. So that's going to give me 1/2 y squared minus 3 dy. Honestly, for this one right here, I feel like you could do this on your own without a calculator. But since it says use a calculator to find the area, just put this into the calculator and see what you get. Obviously, you can't really do y, so change your y's into x's on your TI-84. And then call it a day to find the area there. All right, that's basically it in terms of 5 and 6. So for this one, make sure that whenever you have something in terms of dy, you're doing right minus left and that everything's in terms of y. So that means that your limits of integration are in terms of y, your integrand is in terms of y, your differential is dy. So making sure that if you have something like this, where you can't do top minus bottom, because then you're going to have something like this, where you have the same thing with top minus bottom, which we can't do, then most likely you're going to have to do right minus left.